is not an easy job. In a small supermarket like the one we saw today, I cannot force him to go and bring a centralized ammonia refrigeration system. It will be very expensive. So the installation is too small. And therefore, unless we have a small package ammonia equipment, we cannot force him to go to that. As far as the big word of energy savings, which everyone of us like to see it, I think, although I agree on the principle, but I don't think we are giving it the easy term that the public can use. And I am of the opinion that an advice is as good as the general public can use. It's not enough to say very nice words in a closed room and everyone cheers you and smiles, and when you go home and try to physically implement what has been said, you cannot do it. That is not good. The good thing is that when I say something, I need to tell you step by step how to use it and how easy it can be. Now look at, what do we mean by energy saving? We need to cut the energy we use. Cutting the energy we use under the same certain conditions depends on many things. Why you want my motor to be a very good efficiency motor, 99%, to save 5% of the power consumption and leave the power station kicking out 60 or 65% of the heat in the sky because the efficiency of the gas turbine is only 36-35%. Why you don't do a combined cycle over there? Why you don't utilize the heat there and produce refrigeration from absorption systems? This is one of the issues. How much? This is number one. Number two, some people say screw compressor is better than reciprocating. Okay, fine. Centrifugal is better than screw. Fine. How much is the saving in difference? 1%? 5%? What does that mean in kilowatt hour rather than kilowatt? This is what I want you to be aware of. I have a motor, 100 kilowatt, and I do want to claim that the compressor driven by this 100 kilowatt is the best. So another man comes and says, okay, we have a system that can drop the capacity of the motor from 100 kilowatt to 90 kilowatt. Fine? Okay, how much you want? He will probably need the price of a motor for that. I'm not saying it's wrong, but what is the alternative? Look at yourself as an end user. If you don't have a proper 100% sealed door, what will happen with your cold room or freezer? It will continue running 2-3 hours during the day extra what it should have been. So you already consume 200 kilowatt hour without knowing. You did not use your system the right way. You did not do the right insulation on your system. You are not doing the right operation and maintenance. All those things, because ultimately your bill is kilowatt hour. And the running cost is much more than the initial cost. It is true that the savings, you go to the better efficiency equipment, but before you ask for that and look at it, do a feasibility study. Look at your practices. Do you practice your job the right way? You may save over 10 years or 5 years or 20 years, much more than what you can save when you say, I want to use a better system, especially on partial load. And this is the tendency of everyone now talking about those things. I think the operation and maintenance and the after-sales service is very important to your total bill. Although it is also important that you look at those small items to enhance your system, but don't make it the issue. You start with the small things. Teach your staff how to save energy by having proper practices of operation and maintenance. At the same time, do the right evaluation, hire the right engineer or consultant to do feasibility study on the variety of systems or motors or compressors you are going to bring. And there is a common mistake which everyone, as we said, all of us uses. When you talk about a compressor, you say this compressor is a 5 horsepower or a 5 kilowatt. This is not the right way to define a compressor. This is the right way to define a motor. The compressor, you only define it by the volume flow rate of the refrigerant. And this is very important because the same compressor can work at minus 20 degrees centigrade, can work at 0 degrees, and can work as air conditioning equipment. And in all those, it is using the same volume flow rate because it is confined within the same RDM and same specs. But the cooling capacity of your system has nothing to do with the volume flow rate. It has to do what we call mass flow rate because the heat load is m dot Cp delta T. And this is what you care about. You care about the mass of the refrigerant per hour which you circulate inside your evaporator. While your compressor doesn't care how much cooling you are making out of it. It cares to deliver to you the volume flow rate required. So the volume flow rate is different from the mass flow rate. The mass flow rate decides the size of your motor because the mass flow rate, when it is big, you need a bigger one. And therefore, the same compressor, when it is fitted with an air conditioning application, it takes 3-4 times the motor size of the same compressor when it is running as a freezer, because you have very little capacity in the freezer at that time. The mass flow rate of the volume flow rate is too low because your density is low. And this is what we wanted to put to your attention. Operation and maintenance, we spoke about it. And the poor guys, the maintenance staff is the one caught in the middle. The owner demands that his equipment runs perfect, but he doesn't buy spare parts. And he always criticizes the manufacturer, the contractor, and his staff. And where is your pocket? If you don't give me the money to buy the ingredients, I will not cook for you. So this is exactly the same thing. Energy saving, we spoke about it, and I think I don't have any more because we want to start talking about. I'll go through the presentations. I made about 7 presentations. I was hoping that I will have a lot of time to talk about it, but time is very limited. So what I will do is I will go very quickly just to give you an idea, and whoever has a question, please write it. If we have time today, we will answer it. Otherwise, we will answer it tomorrow with the questions and answers, which we will hopefully have time for. Substance within a certain time and to a certain temperature, but not is an open thing. Therefore, we call it, its concern is to drop the temperature of substance, whether it is solid, liquid, or gas, below surrounding temperatures in a definite place and time. Now, mankind and all these stories, no need for it, but we knew this, and mankind knew refrigeration long time ago. Refrigeration was known and invented before air conditioning because mankind used it mainly to transport meat from America or Australia to Europe, and even by cutting ice from Hudson River and cooling the meat during the journey. No. Okay, thank you. Just like a funny story, Kelvinator was the first company to produce household refrigerators, and they celebrated in 44, they celebrated producing how much? It doesn't work. I will go and use the slide. No, I need the slide to move. 67 refrigerators, and made a big party when they invented the first group of refrigerators, and they sold it during that time. So That was in it's okay. We don't need it. Okay. Okay. That is the food behavior. I want first to tell you that I am a mechanical engineer. I learned about the food staff working with a lot of pre-harvest and post-harvest engineers and talking to the clients and listening to their problems, trying to solve it. So I learned some about the food handling and transportation and safety and things like this, but in no way I can claim that I am a specialist in food industry. So I would like anyone who is specialized in food safety or food handling and has a better knowledge that can be added to what I'm saying, please do not hesitate to talk. I learn from you the same way I give you what I know. I like to have from you, so whatever you know, so we can enrich and work like a team. Okay, so there is no, the old days they used to say the man of every trade or the hero. There is no hero these days. There is a hero team because our life is so complicated. The modern life has so many things and activities and trades that no one on earth can master a few of them rather than mastering them all. So we need to be a team, please, and whoever knows anything on his line, don't hesitate to participate and share with us, and we will appreciate too much you teaching us something new, and I would like to do it. Therefore, what I write here, if it is true, it is true. If it is not true, I would like anyone to confront me and correct my information if it is wrong. The fruit is like any alive thing. It's like us. The fruit, when it is on the tree, it eats from the mother tree, it takes the food from the mother tree and loses bark also due to evaporation, and like what we do from respiration, evaporation and things like this. So while it is on the tree, we have no problem. Even when it is matured or ripened and it's ready to be harvested, it is still on the tree until you take it out from the tree. Once you take it from the tree, the fruit itself has no more a source of food, but the germ is still alive, or the seed, the germ, whoever doesn't know the germ, the seed is still alive, and it has to eat something, and it breathes, so it eats out of the fruit itself. That's why by time the fruit decays or deteriorates. Okay? Now the higher the temperature, the faster and the more energy that seed will need, and therefore it will eat more from the product. And the higher the percentage of oxygen around it, the more and the better activity it will have, therefore it will also eat more from the fruit. So why we chill the fruit? We chill the fruit, number one, to make the seed feel sleepy, so it doesn't breathe too much, it does not respire too much, and therefore it will not eat too much, so we extend the life of the fruit. Also, we, for the expensive fruits like apples and pears, those we would like, sometimes the apples are especially those from California, when they are ripe, they can stay 2 years in the stores. And therefore, those are items that can bring you a lot of money. So the more you store them, the better it is. Therefore, to store it for a longer time, what do? We remove the oxygen, or at least make it very low. In an atmosphere, we call it CA, controlled atmosphere, or ultra low oxygen atmosphere, or completely fumigate. If we do not want to use the seed, then we kill the seed. We kill the seed by preventing the oxygen. And we put the oxygen out, we put nitrogen inside. So this is why refrigeration is required and how refrigeration will extend the life of your product. Simply because, number one, when the temperature is very low, the germ tends to sleep because it's very cold and doesn't breathe, and thus we don't lose lot of the fruit quality and the fruit weight. And if the oxygen is low, it does also the same thing. So what we need to do in our refrigeration system for fruits and vegetables, draw as much as you can from the oxygen, lower the temperature as much as you can to the limit that it will not destroy the cells of the particular fruit or vegetable. This is the whole story which I was trying to do through this. But I did not mention about the ethylene and fermentation. When the fruit is ripened and the temperature around it is hot, it starts, the tree and the fruit itself start producing ethylene because of the stress, the heat. It's like you, when you are nervous, you have a lot of adrenaline in your body. And the same thing when the temperature is very high, and the tree is under stress, it starts producing ethylene. And this ethylene, what it will do, it will ripen the fruit much earlier. It will make it mature much earlier, and ultimately it falls down. Therefore, after you also harvest the fruit, try to remove the ethylene out completely from the place by ventilating the area. And we will be talking about the banana, how we ripen it, by injecting CO2 or ethylene. Do not store colored products with non-colored products in the same place. If you have watermelon or tomato, don't store it with a cucumber and lettuce, because the colored fruits inject a lot of ethylene and they will shorten the life of the other products. Therefore, try to separate those things from each other. This is what we said. Bananas. This is how you will, when the bananas are harvested, they are harvested at point number 2. They are ripened. Sorry, they are mature but not ripened. They are still in a green color, and we give them stored in very well ventilated and cooled stores. They could stay 6 months until someone asks for it. And this is a funny thing between the wholesalers and the outlets. Do not, by any means, ripen any banana on telephone call or even a written order. You must get your cash money in advance before you put it into the ripening room. I have 1,000 tons of banana in a store, and you call me, Ghalib, I need 2 tons of banana urgently. Please send it to me day after tomorrow. It's 48 hours ripening. Put it in the room, ripen it and send it, and I need it in color 3 or color 4. I told, please come to my place. No, I'll send you a purchase order. No, you have to bring cash, not even a check. Because if I ripen it, and it is in number 3 and number 4, within 3-4 days, if you don't take it, it goes to the drain. I have to throw it out. And this is very dangerous. Therefore, when it goes to the, let us say, the outlet, it is in item 3 or number 4. 5, 6, and 7. At 7 is about to be thrown. 5 and 6, it has to be eaten. So when you go to buy those things from the supermarket, try to buy it at number 3 or number 4, in order for it to stay 3-4 days at your home, at your home. Otherwise, it will be thrown out very quickly. And this is an advice only. This is just a table which shows, in English, it shows the different characteristics of products, whether it is vegetables, fruits, and meat, recommended temperatures, and things like this. Apples and stores, this is the euro, which we should control the atmosphere. The grapes are the same thing. They bring very good money, so we have to make sure that we kick the oxygen out. Before we used to have SO2, and if you recall the old days, whoever is an old man from you will see some SO2 inside the box, or a little thing with emits SO2 inside, in order for it to kick the oxygen out and reserve or absorb the ethylene, because it extends the lives of the grapes. Nowadays, this is not allowed, because they found that it is hazardous to the human being, and therefore they are changing it into ozone. These days they inject ozone in the system. How to decide the size of your cold room? I'll go very quickly on this one also, because this is something that, first of all, when we store inside the room, if it is what we call walk-in, then you only have stationary shelves, and you put your product inside on the shelves, okay, as it comes in its packages or containers. But if you have a big room, and which we call a drive-in, then this is where we need to talk. The drive-in can be either first in, first out, or first in, last out. For sure, the first in, first out is the best practice, which means that I have this room which can take probably 500 ton or 300 ton of products, and if I have only one door or two doors on this side, and this is completely closed, I push everything at the end until it is full completely. When I start taking my product, if I start taking from here, the last one, which is the first one I bought, will be the last one to take, and it will be probably, if there is no continuous good consumption, it will be subjected to be deteriorated, and it will be have or exceeded the shelf life. Therefore, to be able to bring that one, I have to have a corridor for my forklift to pass through. And the forklift, if you are talking about 1 or 2 tons, or 1 ton or half a ton weight of a pallet, then you need a real forklift, which needs about 5 meters or 6 meters corridor to be able to turn and bring my things out. This eats a lot of the room space, and normally you cannot utilize more than 40-45% of the total space of the room volume, because you still have to give a space for your evaporator to throw the air and circulate in the whole room. So therefore, the average is about 40-45,000. The level of the education of the people in this area will never accept to use only 40-45% of the volume of a room which he paid a lot of money for. So he stacks everything as much as like what we saw today in the supermarket. They are stacking as much as they can inside the place where they shouldn't do this. So the other way to do it is, if you wanted to 100% fill it completely, but to a level below the level of the evaporator in order for the air to circulate, then you have to have doors from the outside. If you need to have doors from this side and doors from this side, you will lose also a space for the forklift just to go in and out in that area. So we have a first in, first out. When we design things like this as engineers, I always design it on paper and send a recommendation to the owner, but in reality, when I visit after 2-3 years, I find the whole thing is in a mess, because no one listens. He wants to take the best out of it, and therefore make sure that you put a little bit of a margin when you work, because no one listens. We don't go by the book all the time. So you need a safety margin when you do your design for the systems. The owner has his own point of view. He does not accept what you write, then at least put a safety margin on your equipment, so, and room. Okay, this is what we call wet or pre-cooling. This is a very important subject, and whoever deals with mainly grapes, he will find many of those in his place, because now it is a standard in Europe and America that they will not buy the grapes from this area unless it is already pre-cooled at the farm. The reason for this, they buy our grapes because it's an early crop. Before they start harvesting it in Europe, which is called, it's already ready to be harvested here, and therefore we sell a lot of it, especially in this area. I worked with farms in Saudi Arabia who used to produce 30,000, 40,000 tons of grapes, and most of it goes to Europe and South Asia. So they come and physically inspect. They send a supervisor who sits and lives in the farm and goes with us to the farm and see that we are doing the pre-cooling. What is a pre-cooler? This is the pre-cooler. Is actually a piece of equipment. Okay, thank you. This is actually a piece of equipment. Okay, you see this, yes, which is very simple. This is a coil, refrigeration coil, and this is a little bit of a tank at the bottom here, which has some water. This is a pump which circulates the water from here into a shower on top of the coil. This is a fan which sucks the air from the room and pushes it from the bottom up and goes. It is counter flow to the water, so the water can be suspended in the air for a long time in order for it to evaporate and cool and saturate the air. The refrigerant coming from my condensing unit brings the refrigerant into the coil. The coil cools the water to almost 0 degrees. So you see some traces of ice here, but the remaining water is at 0 or 1 or 1.5 degrees centigrade. And the air comes from the room where the grapes are and is pushed up, and then it goes through the filter here into the room, 100% saturated and at a temperature of about 1 degree centigrade. And it circulates in so heavy quantity of volume fluid, quantity of air through the product, that it cools it immediately. Therefore, my product stays fresh. Then we bag it and we put it in a container. Then the container goes inside the cold room until it is set and it is already waxed and sealed. Why we are doing this? Because it had been proven that by the time you harvest your fruits or vegetables and put it in your open Toyota truck from your farm until it reaches the cold store, takes 1 hour, 2 hours, half an hour, depending how far your cold store from the farm. You already lost 60% or 50% of the weight which you are supposed to lose from the product in this 1 hour, because it is very hot, it is summertime, and there is no ventilation, and the fruit is already under stress, so you start losing a lot of water, not only because of the respiration and evaporation, but also because where you cut it and you harvest it, the wound is already bleeding water, it is still open. While in this one, you saturate the air around it, and there is no way any evaporation will happen in the grapes. So this is what happens with the pre-cooler very quickly, but I can speak about it for half a day. Sorry, this is how it works. This is a room where the fruits, although this is a banana, but we also chill banana. If suppose this is the grapes, we put the grapes here and here, and this curtain is there. Sorry. And this curtain is in that air. The air is coming from the top, and it cannot go from the sides. It has to go only from the sides and go back again, because I already covered it. I did the wrong thing here. Okay. You have to take it out, please. Oh, no. Okay. Okay. So you can see here, it's not moving. You can see here, this is the curve, and I cover it from the top and here. So what happens, the air comes from here and goes through the side and from the side, and we force it to go through the product. Then it goes back from this tunnel into the cold room and being cooled again. The next picture will show you. This is how it is completely closed, as you can see here. This is completely closed and the air goes from the side and the side. This is how we cool the product very quickly and preserve the life, so the weight loss is controlled, and at the same time we extend the life, which is much more important. We extend the life for it. But why we do this, and because we can sell the average $5–6 per kilo when it is new and harvested this way, while it cannot bring even $1 when it is the other way. This is an example which you can do at your home. If you bring a glass like this and you put a fruit inside it, and if you can take the air out of it, fine. If you cannot take it, at least just block it, and the oxygen inside will finish after a while, because the seeds inside will breathe the oxygen, and after that they will die. And if they die, this fruit can stay for a very long time without having any problem, because it has no contact with the atmosphere, no respiration. This is just an example. We fumigate, which means that we remove the oxygen and put nitrogen inside. This is one of the slides. And we go to the second one. Going very quickly because I don't want you to feel sleepy, I know. No, it's okay. Okay. This is a very quick thing here about what's wrong. Go ahead. Okay. Okay, thank you. The freezing methods. We must differentiate between, as we said, holding freezers and freezing equipment. Holding freezers will not freeze your product properly, but they can freeze it ultimately. And I give you a very simple example which you can see at your home. You already have a refrigerator at your home and you have part of it as a freezer box. You go and buy fresh chicken and put it in the freezer box of your refrigerator, because you bought 5–6 of them, you cannot eat them in one day, said I am not going to the supermarket the next day, keep them for a week. When your wife the next day wants to cook it and it starts melting and she starts cutting it, you will find a lot of blood within the chicken itself. This changes the taste. It is true that it is not bad, but it changes the taste and you don't like to eat it. The reason for that is it takes very long time, 5–6, probably 10 hours for the chicken to be frozen at your home, while it should be frozen in 40 minutes when it is frozen properly at a freezing plant. When something like this happens, what will happen? The shell, which is the outside part of the chicken, will be frozen very quickly and it will be solid. And this is exactly what Richard was talking about in the morning, where to measure the temperature and how. When it is frozen from outside, if you bring a needle and you punch it inside, you will find that the core is still not frozen, because the shell outside is exposed to the very cold air, and therefore it freezes very quickly, the skin. Once it is frozen, it prevents any expansion inside when the meat inside is frozen. And when the meat is frozen, the volume gets bigger, simply because very high percentage of the chicken is water and blood. So what happens? The nerves or the blood starts exploding, and it is ultimately distributed within the meat itself. So when you melt it to eat it, you will find a lot of blood outside, which doesn't look good. and also the taste will not be very good. If you freeze it at the factory in a proper freezing equipment, we call it plastic freezing or quick freezing, and you make it at home, you will find it as if it just had been kept and there is no blood in it, because you froze it all at one time, and therefore it contains the taste. It is true that probably the value is the same in both cases, but the taste, the tenderness is totally different. And therefore, we say that do not use holding freezers for freezing your product. You use plastic freezer. There are many ways of freezing. Plastic freezing by convection, there is by conduction. There is cryogenic freezing, which not in your industry, mostly in chemical industry. And there are some specialized freezing systems. Whoever is interested, we can elaborate on it. But I will give some photos on them. You could see like those, I'm sure you see those mostly in this part of the world, because we have a lot of hamburgers and chicken nuggets. And that one is also what we call IQF, spiral freezer, individual quick freeze units, and those can freeze the product in less than 30 minutes. But they have to be small pieces, and they cannot freeze very quickly the big pieces. The big pieces have different equipment. This is also, that is a built freezer also, and you can see this is a conduction. In conduction, you remove the heat not by air, but by direct contact of the body, which is subjected to very low temperatures by the refrigerant, and immediately it freezes. As you can see, these hamburgers are taking place. There are other ways of freezing, like in Mecca, because we freeze the carcasses which could be a whole sheep, and sometimes even the cow is cut into two pieces, two halves, and the camel is in four halves, and still we can freeze it by dipping it into liquid nitrogen. So there are a lot of other freezing facilities in the area, and ultimately if you have a very huge piece of meat and you want to very quickly freeze it, you can have it by either convection or conduction or both. And if you are using the convection, you use that type of freezer. If you use the liquidized type, you could dip it into liquid nitrogen, which had been available in Mecca since the 1980s. Ultimately, I just have a little thing here which says definition of low temperature. Low temperature, like anything, is something relative. If you talk about air conditioning and someone says 20 degrees centigrade, you see that it's very cold. 18 degrees centigrade is very cold. This is very cold in air conditioning. In cold rooms, 0 degrees centigrade is very cold, because below that you start having freezing. In freezers or holding freezers, minus 20, minus 30 is a very good temperature, but not very low. Minus 40 for freezing the food is a very low temperature. But if you talk chemical industry now, and you want to liquefy any of the gases, butane or anything, you talk about 150 minus, which is, let us say, Kelvin. And you start talking about very low temperature, so 200, minus 200, or minus 150 will start talking about low temperature. So it's a relative thing. And these are the applications of it, and for sure we have low temperature refrigeration systems, but the last one is what we use in medical applications, where we keep the genes and some other things under very special, very low temperatures, which can exceed minus 200 or minus 150 degrees centigrade. This is the second one. Okay, we have time, inshallah. How to select your refrigeration equipment. Before that, let us say potato. Okay, this is an interesting subject. I had a separate presentation on onion and potato because they are, number one, similar but with different final conditions within the store, but the application itself is similar. The second thing is they constitute part of our daily required food. So I give you an example. In Saudi Arabia, they consume 1,200,000 tons of potato, 1,200,000 tons of onions a year. And they produce about half of that, or probably 800,000 tons of each, and they import the rest. So because we produce all that quantity, and we only have 2 times to harvest and plant those things during the year, we have huge facilities in Saudi Arabia for onions and corn and potato. And I wanted to highlight this particular issue to you because I'll go very quickly on it. There are many ways we can store it in this form, which is, we call it perforated floor, where the cold air goes in tunnels under the floor, and it penetrates the potato or onion and goes, the hot air goes up, sucked by the evaporator and goes back again. This air of potato produces unbelievable quantity of heat because the germ heat is too much. And the way the onion and store are stored, it goes into certain specific stages that must be done. The first one is, before we use any cooling, we have to ventilate it. When we harvest it from, especially in summertime, the temperature of the onion and potato can be 55-60 degrees centigrade because it is normally on the upper side of the soil and the sun is directly on it. It is very, very hot, the temperature. So we need to remove that heat very quickly. This is number one. Number two, whoever involved of you in this type of business, when you harvest potato or onion, you have to stop watering the land 3-4 days before harvesting, because you want the leaves to die and to dry a little bit to help you close the neck very quickly when it is stored. If the neck is open in onion, and if the potato is still very fresh and you put it inside, you suck most of the water, and the majority of the onion and potato are water. So we have to close the neck, and the roots, they have to dry very quickly. And therefore, what happens? We cut the water from the farm, then the leaves of the onion start falling down. The machine comes. We have a machine that has knives, scissors, and it cuts the leaf, it sucks, there are fans which sucks the leaves up, and the knife cuts it. It's like cutting your hair. And the next machine comes after it, and it pulls down the crop from the ground. The third machine takes it, and after that it gathers it and put it through conveyors into a truck. So the trucks are going parallel, then you put it into this store. Immediately you fire your ventilation fans, so you can take the heat out of it. Even if the temperature outside is high, still it is lower than the temperature of the product. What you do, you cool it a little bit, and at the same time, you close the neck. It's like your onion. When it is fresh, you can see it. And if the onion at your home stays a week without you cooking it, or 2 weeks, you start seeing the green leaves coming up again. And this is from the seed, because it's eating the meat of the onion which you bought it for. And therefore, you don't need that seed to come. So whenever you see a little bit of a green leaf in your home, don't be happy, cut it. Otherwise, it will eat all your onion and you will throw it in the garbage. This is one. After that, you start what we call quick cooling. So you drop the temperature to a certain level, which is about 15 degrees centigrade. Then leave it another 2 weeks at the same temperature. Okay, we call it curing time. The curing time, if there is a wound in the potato or there is something not good, even it shapes the potato and onion, that is during the 15 days. Then after that, you have another 15 days slow cooling until it reaches the 0 or 1 degree centigrade. Then it sleeps for 6 months. This is how you do your cooling of the potato and onions, because I am afraid of time. So I remember what I wrote and I will just give it to you straight and we will go through the slides quickly. Now, we spoke about this time, but there are a lot of ways of storing the potato and onion in boxes. There are boxes and sacks. Some sacks can take 1 ton. And we will show it to you now that you store the potato inside it. And some rooms of potato I designed and worked with, it takes 1,250 ton in one room. And you can imagine losing 1,250 ton if anything goes wrong. Now the potato inside, if it is at 5 degrees centigrade or 2 or 3 degrees centigrade and you want to take it to sell it, you never sell it at this temperature, because what will happen? What will happen is what we call thermal shock. If you take it from 2 or 3 degrees centigrade, put it in a truck, with 50 degrees centigrade outside, it will have a thermal shock and a lot of condensation will happen on it, and it will be subject to injury. So there is something what we call reheating the product before you ship it outside. And therefore we start ventilating it. And you will be amazed if I tell you sometimes it takes 1 week or 2 weeks with continuous ventilation to heat the potato, because the cooling capacity stored in 1,250 tons of potato or onion takes a lot of time to raise the temperature. It's like if anything goes wrong with the freezer room, all of you work on meat, and it takes 24 hours probably to change the temperature. And this is how things are calculated in this issue. Now, onions, they need very dry atmosphere. So the relative humidity in the onion room should be about 70%. The temperature can be 0 or even -1 degree centigrade, no problem, the air. But the product is about 0. The potato, the higher the relative humidity, the better the situation is, because you contain the relative humidity much higher. Now the temperature is an issue in the potato. Temperature, we have 3 types of potato. We have what we call seed potato, table potato, and processing potato. And everyone has a different application. Seed potato, which means the small seeds, good seeds from the potato that we cannot sell, we store it in order for it to be ready for planting on the next year. And this has a separate issue. I can talk with you about it, but with the lowest possible temperature and the lowest quantity of oxygen within the room. But not 0, because if it is 0, you will kill the germ and you will have no seed. So the lowest possible quantity that will keep it alive and the lowest temperature, so it sleeps for a long time. When you want to plant it, 1 month before you start raising the temperature. Immediately when you start raising the temperature, you will see the plant start to be growing. And all of us know this, when you plant a potato, it will have some kind of a little, I don't know the protruding thing, I don't know what you call it in English, but
shoots.
Sprout, yes. You will see a little bit of a sprouts, and this is what makes your new potato plant. So that is the seed potato. The table potato or the cooking potato, try to kill the germ. This is number 1. Number 2, drop the temperature up to 4 degrees centigrade, and this is the best. When you talk about the third one, which is industrial potato, and this is something for your kids, I will tell you an important issue about this. Industrial potato, which is either French fries or chips. Those things are not stored at lower than 12 degrees centigrade. Normally 12 to 15 degrees centigrade. Why? Because the carbohydrate in the potato changes into sugar at lower temperatures. And if it is changed into sugar, when you raise the temperature, the sugar doesn't go back again into carbohydrate. It stays as sugar. When you fry it, the sugar becomes carbon, and you will see little black colors in the potato. Therefore, when you buy any of those products from the supermarket and you fry it at home, if you start seeing spots of black color, this means that this is not a good product or it has not been stored properly, because they drop the temperature down to 8 degrees or 5 or 6, and the carbohydrate changed into sugar, and when they fry it, it becomes carbon, and that's why you have black colors. That is on the French fries. On what all the kids, and probably all of us also, we like the chips. There is a bit cheating in the chips. You see that with the flavor of different flavors. They put you 10, 15 different flavors to make you love it. And this is actually a selling point. But they don't do it just because they like. I like to have the pure ones. They simply try to cover the black spots if the refrigeration was not correct. And therefore, if you buy chips without any flavors, and it is clean, then it was stored abroad. If you buy the same one with the flavor and it is clean, it doesn't mean that it has been stored, because it has been covered by something else to show you that it is a flavor, but could be stored well, but there is a little bit of cheating in this issue. That is from the potato, because it is very important, and onions. We need those things. You can see the boxes, and this is the one with the evaporator here. You need a question now?
Yeah, yes. It's a domestic question. That I heard from my mother that the potato has to be stored without light. I mean, when you store the potato at home, it has to be stored without light. I mean, in darkness.
Yes.
There is something behind that.
Nothing wrong. I bring onions and potato, and they stay 1 month in my home without any problem. The reason for that is I already bought it, and it's a smaller quantity. If I lose 5% or 10% from 1 kilogram, I don't feel the difference. I only want to eat it. Okay. There is nothing wrong with the quality of the product. The same thing with the onion, as long as you don't have green leaves coming out of it. Once you start having green leaves, you touch it from the bottom and you find it soft. Why is it soft? Because it started deteriorating and the food is being sucked by the new leaves. But the potato is already closed. Now you could, sometimes the onions stay at my home 2 weeks or 3 weeks without any problem. If we are in the summertime, and you put your AC off when you go to work to save money, maybe your onions will be rotten after a week or 10 days. But if you keep the air conditioning running, you have no problem. Quality-wise, no problem. If you were the owner of the store with 1,000 tons, you care about the 1% or 2% because it is 20,000 kilograms, it is 20 tons. But for you, it's not a problem. Yes, sir.
I've heard the story in the dark, and my understanding was to stop the potato sprouts because they're poisonous, and therefore you store it in the dark and it's less likely to sprout. And that's why your mother said don't store it in the light. So
yes.
Also it might have an effect, I'm not sure obviously in the light, whether that's just in the living potato. Obviously it goes green, and the green solanine, which is again poison. So that's another reason when you have an association with light.
100% correct. Because also, what is light? Light gives you energy. Okay. Now you know that. Light gives you energy, and you know that the sun gives in this particular part of the world. I'm doing the research study for a customer right now. 6.9 kilowatts of heat per square meter per day hits this part of the world. And you can imagine how much of this is reflected on the majority of it when it hits a solid place like the asphalt. If you have marble, all of it is reflected on. This is energy. So the mother is correct when she said put the lights off, because it's energy number one, and it initiates to keep the seed alive. It eats more, and you start having the sprouting. Yes, sir. Put it on. Bush.
Just regarding the French fries part, I couldn't understand how it should be stored at 12 degrees Celsius, and if it is less than that, it will convert to sugar. When I'm getting it, usually freeze it
Okay.
from the market.
Okay.
So I couldn't understand this point.
No. You don't need to understand. Frozen is frozen, finished. I'm not talking about the frozen products. I'm talking about the fresh. Once you are freezing it, they freeze it, the quick freezing. You cannot also freeze the French fries at home normal, because also it will have a similar problems. Number one. Number two, I said industrial potato, and the industrial potato for chips is different from industrial potato for French fries. Not every potato you can store it, not every potato you can use it as French fries. The French fried potato is long, the variety, okay, there are different varieties. It's long, and it is shaped very clean, and normally they use the first generation. They don't like to use small pieces and regenerate from the same one. They buy a new generation again because it is expensive. Making the French fries from the potato which we buy from the table potato is a different issue. This is you cook it at home. But what you buy, especially the long ones, which you buy from the main fast food restaurants, this is a special one. The chips is round and small. They don't accept big potatoes. Table potato can be as big as this one, but the chips, they must be like the tennis ball or a little bit bigger. And they make it chips, and this cannot be French fries. And therefore, I am talking about the fish product. Anything you freeze goes out from completely from what we are talking about. Because you freeze it, what we call plastic freezing, and you do not change the carbohydrate into sugar, because it's like the meat. You give it a sudden shock and you change the whole characteristics. Okay. So these are boxes, and this is the one which I showed you earlier where the air is circulated. I'll show you the ventilation. We have another one on ventilation. Okay, just give me a minute. This is what I explained. This is the ventilation, and you could see the mechanism here. And you observe all the motors, and you could see the openings automatically. One motor can drive a chain of 20 or 30 openings to give you the ventilation on the side of your cold store. Humidification and dehumidification. This is for the potato we spoke about. French fries and so on. These are the dry air properties for CO2. There's a lot of things here to sprout inhibitors, which we said that you need to stop it from sprouting. Heating the potato before we eat it or before we take it to sell. And the quality control, whoever is interested, we can talk about those things. Yes, I want to give the mic to someone. Here or there first? Anyone there? Only you? Okay, yes.
Okay, regarding the potato storage.
Yes.
Regarding the bulky shape of storage.
Yes.
Where you will have on the floor, you will have the cooling coming from the floor towards the ceiling,
Yeah.
coming back and ceiling. I have two questions actually. The first one is, okay, you said that you have stages of cooling the potatoes.
Yes.
Does the air changes inside the cold store changes in each stage to the other? And the other question is, how you can determine the static pressure of the pan, either it is centrifugal or axial, with this irregular shape of storage? bulk storage, like we said, because you have a height,
Okay.
1 meter, 2 meter, I don't know, but how you can imagine how strong is your
Yes, we have
structure?
this, yes, okay, thank you. Good. So you have two questions. Number one is the air changes. First of all, we do not have air changes. Any cold store is like the minimum air from outside, the better for you because you save energy. It's like your cold room or your freezer.